Okay, 7th graders, so this is kind of the lesson today. We started with review for the quiz tomorrow. So the first question was this idea of looking at a shape on a grid, multiplying the lengths, and then answering a bunch of questions in the table. So if we look at the A part, it says multiply the original length by 3.2. Sorry, it's not 3.2, but actually 3 over 2. Okay, so that's 3 over 2 here. So remember, we actually just looked at the distance there, which is 2 units. And then we looked at the distance of the height, and that was 5 units. So if we're going to take the original lengths and multiply them by 3 over 2, then we're going to get these two numbers here off to the right. So it's 5 over 1 multiplied by 3 over 2, and 2 over 1 multiplied by 3 over 2, which gives me the new lengths of 7.5 for the height and 3 for the width. So the question asks for the data points, right? The new coordinates. Okay, so then I just have to think the origin is going to stay the same, but then I'm going to make the base longer by making it 3 and 0. And then this one, the height is 0 and 7.5, again, because I have to go all the way slightly above my axis here to put those data points out there. Okay, so and this is 3 and 7.5. So that's the first part of this question. Okay, so after we find the coordinate points, we just have to fill in the chart now. So we got an original picture was a distance of 2 units, and the original height was 5, and so we just throw in these numbers that we calculated already. So that's 2 to 3 and 5 to 7.5. Because the picture is getting larger, that's why we called it an enlargement. And then what's the constant of proportionality? This is, again, 3 over 2, because that's how much larger we made the new picture. Okay, so it's given in the question, so there's not much to calculate. Sometimes you could be given data, and then you can take the ratio of the data to figure out what is the proportionality. Okay, in our second question here, we had like a square pool that was 8 meters by 8 meters, and then we're supposed to create a scale drawing which reduces it or makes the pool smaller on the drawing 1 and 200. So it says use an equation or a table to show how you get the scale drawing lengths. Okay, so I started the table in class, and then I talked about the equation after. So with the table, we go with the original picture and then the actual, and then I put the scale in here. So this is a little bit interesting. I go 1 to 200, but the actual is 200 times bigger. So the original, you got to think this is going to be the drawing. If you're kind of wondering what that means, that's the drawing that is going to be for the scale drawing. And then we don't know the length of the side because we're going to calculate that. And then what we know is that the friend's yard is 8 meters. The pool in the yard is 8 meters by 8 meters. So one side is going to be actually 800 centimeters. So that length there. Okay, so to go from the actual to the drawing, it was like divide by 200, and that's what I've kind of highlighted here in black. So if you take 800 and you divide it by 200, that's how I get this 4 here, and that's going to be 4 centimeters. So when we actually do the scale drawing, so I guess you're going to need a ruler tomorrow, you actually have to draw 4 centimeters by 4 centimeters, and that's going to be your scale drawing of that square pool. Now, the second way to do this is through the equation y equals kx, because the scale factor is 1 in 200, so then you go y equals 1 over 200x, and then just figure out the relationship between the drawing to the actual pool. Now, the thing that gets a little confusing here is I called this x here and also x in here, but they're actually they actually mean two different things. Okay, x in this case, okay, this is actually going to be the actual pool. Okay, so the actual length of the pool, which is 800, and then I times by 1 over 200, that gives me a y value of 4, and then the y actually here becomes the drawing. Now we just have to be careful or thoughtful when we do this with the math, because sometimes it is easy to mess up the x and the y. And normally it is x and then y. But in this one situation, my actual y is represented here and my x is here according to the equation. Okay, so x was the actual drawing and x was the actual distance and y was the drawing distance. Okay, so our last question here, which we didn't have time for in class, was this kind of shark logo question, where we have a logo in the shark post that measures a certain distance, 5 5/6 of an inch, and then we're supposed to find the actual length of the shark based on a scale of, it says 1/3 inch on the drawing corresponds to 7/8 of a foot in real life. Okay, so what this means is, for the scale, the drawing, for every 1/3 of an inch, okay, the actual is 7/8 of a foot. Okay, and so the length, okay, the length in the shark post, it says it's actually 5 5/6 inches in the shark post. So using the scale, we got to figure out what this number is. And I put x here. Maybe I should put something else, but I'll just put question mark. We don't know. So we have to figure out to go from here to here. But we have the way to get it because we have the 1/3 and the 7/8. So if I make this the x and the y, I know that the constant of proportionality, or the scale factor, is going to be y over x. So that becomes 7/8 of a foot. Actually, I'll just leave the unit out for a second. So 7/8. Okay, that's not going back for some reason. Pause. Okay, so I'm going to leave the unit out, so I'll just scratch it out, I guess. 7/8 divided by 1/3. So that's 7/8 times 3/1. So we got a weird scale factor. It's like 21 to 8. It's not a nice number, but we got to work with it. Okay, so that means from an equation standpoint, y equals 21/8 times x. Okay, so in this case, this is the x right here. So y is going to equal 21/8 multiplied by 5 5/6. Okay, this is kind of ugly at this point, but we gotta still do it. So y equals 21/8 multiplied by 31 plus 5 is actually 36, 35. 5 times 6 is 30 plus 5 is 35/6. And so I need to multiply this out in order to find the new length. There's a little bit of simplifying here. This can be 7, and this can be 2. So then I have 7 times 35, which is 245. And then I have 8 times 2, which is 16. Okay, so let's find a nicer fraction though. So that works out to 15 5/16. Okay, it wasn't really magic that 15 appeared. I actually had to do it on the calculator first. So what does that, again, number represent? Okay, well that actually represents the actual size of the shark logo for it to be proportional. So 15 5/16 of a foot, or 5, yeah, so that's pretty long. And I think that's it for this question. All right, so thanks for listening. See ya.